Hi everybody, in today's lesson we're going to be talking about properties of rational exponents, and in today's lesson we're going to add and subtract these terms. So let's go ahead and look. Now, first of all, let's talk about what are like terms, alright? Like terms are something with the same variables that have the same radicals or exponents. So sometimes we can visibly see them and sometimes we have to simplify in order to see if they are like terms. So let's get started. We are going to attack 6 problems using this concept of adding and subtracting like terms. So the first question says, are they like terms? If so, perform the operation. If not, why? If you look at example 1, you could see that they are not like terms because I have square root of x and square root of y. Since x and y are different variables, they are not like terms. So they are not like terms because square root of x and square root of y are not the same. So therefore we can't add them. Now if you look at example 2, we have 3 times the cube root of x to the 5th power minus 2 times cube root of x to the 5th power. Well, we have cube root of x to the 5th and we have cube root of x to the 5th. So yes, they are like terms, so therefore we can add them. And we have 3 minus 2, so 3 minus 2 is 1 cube root of x to the 5th. Now that 1 is really unnecessary, but the other thing I'm noticing is that I have 5 x's inside and I need groups of 3. So if I divide this by 3, I would say that 3 goes into 5 once with the remainder of 2. So what that would mean is x to the 1 would come out and 2 x's would remain inside the root. Now there's also a 1 in the front. You can write that, but you don't really have to. And that's what that expression would actually simplify to completely. Alright, let's look at number 3. Are they like terms? Well, let's see. I have 2 times the square root of 3 minus 4 times the square root of 4. Now, I do know that the square root of 4 is the number 2, because 2 times 2 breaks down. And then that gives me 2 square root of 3 minus 8. And looking at these terms, right, 2 square root of 3 is not the same as 8. If 8 had a square root of 3, I would have said yes, but since that one is missing the square root of 3, the answer is no. And the reason is because 8 does not have a square root of 3. All right. So let's look at example 4, 5, and 6. So in these, our job is not to say are they like terms, but just to simplify them if we can. So we're going to add them if they are. If they're not, we'll leave them alone. So let's look at example 4. Looking at example 4, 5 square root of 2 plus 6 times square root of 8 do not look like terms. But I do know that I can break down the number 8 to 2 times 4, and this 4 breaks down to 2 times 2. Since it's a square root, I know that I need groups of 2. So here's a group of 2's. What that means is the 5 square root of 2 just drops out. Nothing, I can't do anything. 2 doesn't break down any more than just a 2. Plus, we have a 6 out in the front. Another 2 joins that 6. And now we have just a normal 2 left inside the root. So we have 5 square root of 2 plus 12. 6 times 2 is 12. Square root of 2. And as you can see, they are like terms. We have 5 square root of 2 plus 12 square root of 2 is going to give us 17 square root of 2. So we add the numbers that are on the outside if they are like terms. Alright, let's look at the next one. In example 5, we have a 3 cube root of 5x to the 5th minus x cube root of 40x squared. So I can tell that I'm going to go ahead and take this. 5 doesn't break down anymore, but the x's do. So we have 5 times, and then we have 1, 2, 3, 4, 5 x's in there. So I'll kind of leave it out so you can see it. Minus x on the outside, and inside the cube root we have the number 40. Now 40 breaks down to 5 times 8, but 8 breaks down to 3 2s, so it's 2 times 2 times 2. And then we have 2 x's. So that's what all of that all the roots break down to. And since we have a little 3 on the outsides, what that means is we need groups of 3's to take out. So this x could come out. And in the second cube root, this 2 can come out. So we're going to go ahead and move those outside, and everything else I haven't highlighted will stay back in. So we have a 3 that's already outside. This x now comes outside, getting rid of all of them, and we are left with a cube root of 5x squared. And then minus, we have now the number 2 coming out, so here's a 2, and then we have an x that's already outside, and then we have the cube root of 5x squared staying inside. Now if you look carefully, what you're going to notice is both of them have an x cube root of 5x squared. X cube root of 5x squared. And since they are like terms, we could do 3 minus 2, which is 1x cube root of 5x squared. And yes, I'm sure you're thinking this, can I just write it as x times cube root of 5x squared? And the answer is yes, either one of those is a good answer. All right, well done. Let's look at the last one. So if you look at number 6, first thing I'm going to do once again is break it down. We have a negative 4 on the outside, and inside the square root we have 9, which is 3 times 3. And then I see 1, 2, 3 x's plus 5 x's on the outside and square root of x. I can't break down an x any more than that. And then we are going to go ahead and circle 2's. Now, when there's a square root, there's usually a 2 right there, although we never write it. Everyone in here should know it's a 2. So I'm going to go ahead and circle pairs. There's one pair and there's another pair. So those pairs are going to come outside. So we already have negative 4 on the outside. A 3 will join it. An x will also join it. And inside the square root, we are just left with 1x. Plus 5x and then square root of x, since x cannot come out. There aren't 2 of them. So we are left with negative 12x square root of x plus 5x square root of x. And if you can see the like terms, we both have a 5 square root of x, or I'm sorry, x squared of x. X times square root of x on both of them. So really what we have to do is subtract or add negative 12 plus 5, which is negative 7x square root of x. And that's our final answer. So just a quick recap. Remember that we only add and subtract if they are like terms, and sometimes even if they don't look like terms, we try to get them to be the same. If we can, at the end, then we add them or subtract them, and if they are not the same and we can't get them to be the same, like in example number 3, then we just leave them alone and say we cannot go any further. Alright guys, well thank you for sticking around to learn about adding and subtracting like terms. I hope that helps. See you in class.